Hello dear students and welcome to my YouTube channel. In the earlier video, I had showed you how to analyze a given pair of regression equations. We'll be continuing with another question in the same topic of analyzing regression equations. So here we go. We are given that two regression equations of a bivariate data are given as follows. 25x plus 7y plus 8 equal to 0 and 9x plus 7y minus 1 equal to 0. We have been asked to find both the regression coefficients and state the correlation coefficient. So both the regression coefficient, that means we want to find Vxy and Vyx, and the correlation coefficient is R. To begin with, let me tell you the difference in the earlier problem in the last video which I have uploaded. In the earlier video, the regression equations were specific. So we were specified that the equation number 1 is a regression equation of x on y, while the other one is of y on x. Now here if you will see, there is no specification as such. So to begin with, we are going to declare equations as the regression equations of x and x on y and y on x. So let me say that let the regression equation of x on y. So I'll take the first equation as the regression equation of x on y. And if you have seen the earlier video, you know that from this we are going to get the regression coefficient Vxy, and for that we need to write down the equation in the form x is equal to ay plus b. So let us do that. This is 25x right here. Let me rewrite that. So rearranging, we can say that 25x is equal to negative 7y minus 8. We need to get rid of the 25. So this is going to be x equal to minus 7 upon 25y minus 8. If you compare with this, the value of a is minus 7 by 25. And therefore, we have the first regression coefficient as Vxy equal to negative 7 upon 25. Let the other equation be the regression equation of y on x. So that is going to be 9x plus 7y minus 1 equal to 0. And this is going to give us the coefficient b by x. And for that, we need to write down the equation in the form y is equal to ax plus b. So we can say that 7y is equal to negative 9x plus 1. We need to move the 7. So we get y is equal to negative 9 over 7 times x plus 1 over 7. And if we compare the value of a, then this is a, and thus we get the regression coefficient of y on x, Vyx, which is equal to negative 9 over 7. We have put Vxy, Vyx. Now moving on to the last part, that is the correlation coefficient. And if you can recall, the formula for R is plus minus square root of Vxy into Vyx. So this is going to be plus minus square root of Vxy is negative 7 over 25 into negative 9 over 7. So we can rewrite this as, after certain cancellations, this is going to be 9 over 25 with 7 going away and minus minus giving us plus. And the root of this is going to be 3 over 5. And we also have plus minus here. Now, as stated in the earlier video, that R, Vxy and Vyx, they all have the same sign. So all of them will either be positive or all will be negative. Now, earlier calculations has given us that Vxy and Vyx both are negative. So R also must be negative. So in this case, instead of putting it plus minus, we can say that R is equal to negative 3 by 5. So that is the final value, and thus we have completed the solution for the regression coefficients Vxy and Vyx, as well as the correlation coefficient. Hope you understand the solution of the problem and also try to figure out the difference in the earlier video and the current video. Thank you for watching till here. Have a great evening.